Viewers, and welcome back to the Self-Made Auto Channel. Got a 2015 Jeep Patriot. It's got the big 2.4. The guy tells me the money light comes on, or is on. He has an intermittent throttle light coming on, so that's the red one with the little lightning bolt on it. And he also says that when you start it, when it's cold, the temperature gauge is all the way up where it should be, up in the middle, or up near hot. So anyhow, it sounds like they had another shop. They determined it was a thermostat. I think he said they put a thermostat in it. But it's neither here nor there. Let's see what it has for why the engine light's on. Let's see if that's related to the temperature gauge, and let's see if that's also related to the throttle light coming on. All right, folks, so let's have a little gander here. So 15 compass 2.4. We're gonna go all DTCs. And what do we have? Cooling system performance at 2181. I wonder, I don't know if that would cut off the throttle or not. I'm surprised to not see any type of throttle code in here. So what we'll have to do, we'll have to go into some service data and look and see what the actions taken when the code set are, and see what the code set criteria is. Perhaps this one in ABS. He didn't say anything about ABS light or anything coming on, but let's look that up. All right, folks. So we've got. All right, folks, we'll look at it here, the 2181. We come down, it is monitored, ignition on, engine running, no coolant temperature code, so ECT, electronic coolant temp code's present. The set condition, the coolant temperature should change at a specific rate. If it's too slow or too fast, this fault will set. It's a 2-trip fault, meaning it has to fail 2 times consecutively to turn the light on. 3 good times, though, will clear the check engine light, malfunction indicator light. Electronic throttle control light will illuminate on the first trip failure. Bada bing, bada boom. So that answers all our questions. This is probably the problem with the temperature gauge. We certainly can say that it's going to be the problem with the throttle light. So that makes sense. I don't know why it lights that up the first failure, but it does. And that explains why he said it's been intermittently coming on the throttle light. Possible causes: low coolant, thermostat, coolant temp signals, short voltage, shortage of ground, yada yada, electronic coolant temp sensor, inspect coolant temp, related PCM. Sometimes, I think I've mentioned in the past, we'll look through flow charts, so to speak, just to see if there's any relevant information in them. Oftentimes they can lead you, I don't really want to say lead you astray, but they're going to take you the long way around. So it looks like it's primarily using this engine coolant temp sensor 1. Let's see, it's got a bunch of checks there. Probably has our resistance value here for the sensor itself. Anyhow, it's just going to be a bunch of basic circuit checks. So let's see, I think they had a wiring diagram up here too already. Yeah, they did. So right here, engine coolant temp sensor. Looks like it's got other temp sensors there. Engine coolant temp there, oil and intake. So let's see. Signal. All right, let's go like this. Let's just pop back into data here and see if we can see the coolant temp sensor while we're right here. Just see what it's saying. See if we can just search it out. Cool. 226.40 degrees. Well, that's funny because I just brought it inside. And intake air temp is a cool 55.4. And it looks like it said it had an oil temp too, right? Oil temp is 50, so something isn't right. If that's 50 and that one's 50 and the intake air temp's 55, but the coolant temp is 200 and some change, we got a problem, Houston. We're going in deep, folks. We better get these babies out. Coolant temp sensor. I think they live over on the plastic housing on these things. Get this plastic off. Right there. And I thought they were over in this neighborhood. Actually, I think it's sitting right up here on top. And I see where somebody had the radiator hose off. Let me show you where I think it is. So right up here, and you can see where that hose clamp's been moved. So I think they did do a thermostat, but I believe that is our coolant temp sensor. I don't want to wiggle it quite just yet. Just wanted to see if there's anything obvious. Any kind of moist damage. I still don't have my sniffer, so I can't smell mouse piss yet, which is kind of good and kind of bad. But let's get that pulled up on a scan tool. Let's make sure our wire color matches, because what do we have? A purple and some, looks like a purple with the orange stripe there, and make sure we're in the right neighborhood. Let's got her there. We're at what, 230. So let me just give it a little wiggle here to see if it changes. I think it just did just. Oh yeah, so it's kind of flickering around there. Kind of wiggle the harness. Okay, just want to make sure before we unplug it. So let's just unplug it. And 228 seems to be the maximum. And I see a little coolant down on top of the male pins here. So let's grab a little pair of pliers. A little free tip for you. And let's just touch this across two terminals. See if we can take her to -40. No, for some reason it went to 159. So that's weird. It went to 159. I would have thought that shortcut, unless there is a connection problem inside these terminals, which is plausible because there is coolant in there. Let's plug it back in just for poop and laughter and see if that goes back to 256. One thing we should be doing is I probably shouldn't be using OEM data right now. We should be using generic data because we don't want to accidentally have a substituted value. Because see, here's the problem. I don't know how observant you guys are being right now, but look on the screen right here. See, this is where it's going to burn us. See the voltage? 0.6. I unplug it and we go right to 5 volts. That's what we want to see. But look at the coolant temp data PID. It's at 159.8 and it's rock solid. This is where you're going to get burned using OEM data. Now, I'm not talking just an OEM scan tool like this one. This is the YTech. I'm talking OEM data where they're using Snap-on, Altel, Launch, Top-Down, any of them. If you're in vehicle specific data, you're going to see this, and this is where it's going to get you because that is a substituted value. The PCM is filled in because we've probably set some other kind of code. It's filled in a generic value. So let's go here. So we did. So we set a 00 or a 0118. And this is where you get wrecked if you're not paying attention. So let's go back to coolant, 5 volts, and then technically when I short it with the pliers, it should go to 0. And it's at 0.000 volts. So we know what we know. We know it's a liar, pants on fire. We know our coolant temp sensor is bad. Let's get a generic scan tool. I'm going to show you guys, and it's a free little tip you take home with you. So what I mean when we're talking about, vehicle specific or generic OBD2, it's like, let's say when you're using your scan tool and you put in, 2015 Chrysler, Patriot or Jeep Patriot or, whatever you're working on, you put it in specifically under that make and model. That's what we would call, OEM specific data. But when we're doing generic data, we're just going, well, I can't go back to the start menu. We're just going generic OBD2. So it's going to be like your little cheapy code readers and stuff. Those typically do just generic OBD2. So we should be able to find engine coolant temp. Yeah, we did right here. So, which the beauty of generic OBD2 data is there should be no substituted values. This should be just raw dog data, no fill in the blanks. For some reason, we've got one sitting here at 419 degrees. But let's look and see what these do, because that doesn't make sense. telling you how great generic OBD2 data is, and then I'm showing you how much it sucks. But typically, general rule. So now let's see what happens. This should go open circuited when I unplug it, and you can see that this one instantly drops to minus 40. This data pit over here, I have no idea. The one that is 419, let's just pretend we didn't see that. Because typically this is how it should work here. Now we could put a variable resistor in here and you could run it through all the different ups and downs and ins and outs, but basically what we're looking for is 0 to 5 volts, you know, open circuited being 5 volts, which is negative 40, and then shorted together, which typically is 256, which I guess we can do with our pliers again and just see what value that takes it to. I thought 256 was the high end. No, in this case 375.8 when it's fully shorted. So, and it just depends on how it works. If it's negative coefficient or positive coefficient, I think it didn't set a code for this because it is within a given parameter range. It's not completely open and it's not completely shorted. So that's why we probably didn't have a code for it. But anyhow, long way to go about just putting in a $15 part. So hopefully you learned a little something. Napa, who chooses not to sponsor us because we won't let them, and they've never asked, let's be honest, is on their way with the coolant sensor, and it's pretty easy. It literally pops in, takes 2 seconds, you know, piece of cake, wham, bam, bino. But hopefully what we get out of this video is, if you're looking at some data and says something don't seem right, like why is that sensor reading like perfect, you know? If something doesn't seem right in your vehicle specific data, jump over to generic OBD2, because I think technically the rules are that they can't use substituted values. So it's always a great place to go. You'll see me use generic OBD2 data often because I don't like substituted values. I don't like the way that OEM will interpret some data sometimes. So anyhow, don't you waste any time. Go in that comment sections, the questions, the comments, the concerns, Insta, Facebook, you guys know. And just remember, viewers, if I can do it, you can do it. Thanks for watching.